A very good evening to one and all. Center of Excellence in Safety Engineering and Analytics, CoE-SEA, wholeheartedly welcomes all our dear participants to week 57 of the weekend talk on safety engineering management and analytics. The event is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. Today, let's begin this event with this beautiful slogan. Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityoma Amritatgamaya. Praying to Almighty to lead us from ignorance to truth, from darkness to light, and from death to immortality. Now, let me welcome our dignitaries onto the virtual dais. We have Professor J. Maiti, who is the chairman of the center, Professor Obi Krishna, who is the convener of the event, and our expert speaker for the day, Mr. Kevin Chodani. He is a certified industrial hygienist, certified safety professional, and chartered health and safety practitioner. He is recently appointed as the board of certified safety professionals USA ambassador, and he has completed his bachelor in electrical engineering with a gold medal and an international diploma in occupational safety and health from the British Safety Council and post diploma in industrial safety from Mahatma Gandhi Labour Institute. He has over 19 years of experience in Secura Energy Private Limited and Secura Roads Private Limited, Secura Power Manufacturing, Hydro Turbine and Generator Manufacturing and Technology Center, Heavy Engineering Manufacturing at L&T, Hydroelectric Projects at Gamon, India. His expertise in the area of process safety engineering and hazard analysis, ESG, environmental health risk assessment, green supply chain management, ventilation, industrial hygiene assessment, risk assessment techniques, EHS management system, ISO 14001, ISO 45001, legal requirements and compliance, electrical safety, lockout and tag out, fall protection, machine safety assessment, ergonomics, fire prevention detection and fighting system, highway safety management, etc. CoE-SEA is very privileged to have you with us today, sir, and we are all very much happy to attend to. Now I welcome Professor Obi Krishna to kindly welcome our expert speaker.
Thank you, Steen. Thank you for your beautiful introduction of Mr. Kevin. I don't want to repeat what you have told. You have very elaborately introduced the speaker. But I just want to tell one or two my observations. Mr. Kevin is a great supporter of this program. He keep interacting with us. And when I asked anybody who want to speak with their experience, Kevin having huge experience in right from manufacturing, energy, environment, a huge. I don't know any field you have left, Mr. Kevin. You have experience in many fields, and other than this, academically he's very sound. He's gold medalist. That means the academic excellence and industry experience that gives Mr. Kevin really a suitable expert speaker for this CoE-SEA's 57th week. Without standing in between the speaker and the audience, by telling one word, Professor Maiti normally he welcomes. He is heading two departments, so that's why he is so busy and he is held up in one of the meetings. That's why I'm introducing. So thank you very much, Mr. Kevin. Now the floor is yours.
Thank you, sir, for introductions. And I think I want to be a great support to India to make sure that we can have a very strong health and safety professionals across in India to save the human life. Okay, thanks everyone. Let me share my screen now, and what I am expecting now participants to have a more interactive session rather than only one day. So I will keep on posting some of the questions, maybe at least you can use the chat box, and that's what we can have a good interaction because that's what. And then I'm trying now more towards a session with more case studies, real examples, so we can have a great discussion of the right methodology and this is actual and the sharing the right practices of that. Okay, so fine. I'm just sharing my screen now. So the today's topic is incident investigation techniques with a case study. So we'll discuss more about the basics about the technique. So the session's objective is simple. We'll explain at the end of the session. At least you should be able to explain what is incident, the definition is per ISO 45001 and its types, importance of reporting and investigation. So that's we'll understand a little bit brief because you have understood through many sessions why it's important to report an investigation. But when we talk this topic, we should touch upon some brief part on that. Then we'll understand some basic methodology, what we do for incident investigation, step by step process. And then we will evaluate the right appropriate. You should be able to evaluate the appropriate root cause analysis techniques and determine what is the follow-up actions can be done to make sure and then horizontal deployment. So going ahead, these are the topics we are going to cover and incident, purpose of investigation, what are the insights we can get from the investigation, human failings, incident investigation methodology, root cause analysis techniques, case studies, and review of objectives. So before starting the session, let me start with the talk about the incident. So there is a if anyone is referred with ISO 45001, earlier we used letter of other words, right? Sometimes we call accident, sometimes we call near miss, sometimes we call medical treatment incident, and also there are a lot of classifications around the incident. But then ISO 45001 came and then said it's to be considered as a one. But the incident can be two types. One is where there's an injury or ill health occurs. It can be sometimes we refer as an accident, and where there is no injury, but there is a potential to do so. So sometimes it's called near miss, near hit, and even high case like high potential incident or even potential severe event. So there are many words we use it around that. So these are all incident. And when we say the examples, it's not only the injuries, ill health also is covered here. So any like noise-induced hearing loss, or maybe eczema, or maybe any hands armed vibration. Because of that, there is some Reynolds phenomenon and all. So these are all examples of incident. Even fire and vehicle incidents are also incidents, right? So I think that's what the broad terminology about incidents. Uh, Now, coming back to the next part. On incidents reporting, I think we are very clear, right? Any matter, whether it's a small or bigger, any incidents to be reported on time. We can use any medias. It's not mandatory that only to be used only the standard template. So nowadays, you can use a mobile phone. You can call through your office internet telephones or maybe email. So there are multiple ways, but the important part, you should communicate as soon as possible. So one is that the person can be responded faster for the medical treatment if anyone gets an injury, or maybe there is an environmental effect. The response can be given better, and then we can have a lot of mitigation actions can be done on that. So ultimately, it will not go to the major areas, right? Now, coming back to the purpose, right? I think the fundamental is very simple, is to find out the cause of the incidents and to prevent the similar incident in future. So there are many purposes of the incident investigation, but the main purpose is here is to find out the cause of the incidents and to prevent similar incidents in the future and to fulfill applicable legal requirements to determine the cost of the incident, and sometimes it also helps you to do the compensation claims. Now, my questions to the audience now. You might have seen in your career, some people are maybe they're very fresh, or some might be have a lot of years on years of experience. Now, you might have seen some of the lost time incidents, or maybe sometimes very dangerous occurrences, or some these are incidents you have seen. Uh, can you tell me how many incidents you have faced in your life approximately? Maybe you can write down in your chat box. And out of that, how many incidents you have done detailed investigation after that? So there are two questions, and it is again linked with each other. One is how many incidents I'm considering now the critical one, not even the near hits, because near hits are also to be important. But let's say there's an injury happen, or ill health happen, or some medical treatment happen. Those incidents you have seen it, or maybe you have observed that, and then how many out of those incidents you really took part in this investigation. So you can use the chat box. I can just look on the chat box, uh, right? So the normally you will find that many times we do a lot of we might see a lot of incidents, but what we do missed out is that in the investigation we do sometimes we don't do the investigation, or sometimes we do the investigation that is what only very superficial investigation, and that's what, like, let's say someone gets cut injury, what we said, there was a sharp edge of the blade. That's all our investigation is over. Most of the team member does like that, but they never go why that blade was there, what was the reason behind that, and that we missed out. And right, so we'll see understand better, because if we don't understand the cause of the incidents, and we cannot prevent the similar incident in the future. It can be similar type, or there may be causes can be the similar types. It is not mandatory that it will be the exactly it will happen the same thing. Like one incident of electrocution happened with a welding transformer, let's say. The second way it can happen also with the electrical panels or maybe other machines. But you have to understand what was the cause behind that. And if you understand that cause, you can better do prevent that the similar type of future in your organization, in your sites, as well as you can also say the same thing to the other side. It can give a good difference, right? Okay. Now, when we say the causes of the incident, when there are normally the when we I think this weed we know very famous, right? And in normally in agriculture farm you see this type of weights, and normally what we do, we just cut on the top, and again once that gets adequate food and nutrition, again that will grow up again, and that is no unwanted items specifically for the agriculture farm. Now we do only work on immediate causes, right? The agent of injury, what I said, the example, right? We just remove the blade and we said, yes, I've done the correction and my incident is over, investigation is done. Do you think that is okay? No. So then you go to the underlying cause a little bit. Some organization think that okay, not I should not only go up to immediate cause, I should go a little bit more inside, and that's it called underlying causes. So what we go unsafe acts and conditions. So when we say there's a okay, the blade that the person gets injury because of the blade. Now what we do? Okay, he was not knowing how to use the blade, or maybe the blade was located somewhere such type of location where it is exactly location of the work area, so he gets cut injury, or he or she, whoever is there. And then again we say that that's what our investigation, and we said okay, again our most of the corrective action will touch upon that front later, but that's end of our investigation. But we never, most of the time we never go to the root causes, and if we don't go to root causes, again the incidents can happen again, the similar incidents can happen. Now what is the root causes? It's nothing but it's a failure from which other failings grow. So if you don't to work on that, what happens? Like we never go into that. Like for example, let's say there is a cable gets damaged, or one insulation cable gets damaged. Now there is a cut, and people say okay, it's damaged. You put then they take correction and they put an insulation tap on that. That's fine. But what was the okay? They said SAR page was in touch with that. That caused the incident. And then what was the unsafe act and condition during the laying of that cable? Someone has not thought of. So that unsafe acts was there. Now, why it happened? Root causes. Whether our permit to work system was correct in nature, whether our routing was design was correct on that one cable routing part. That we never thought on that. Whether our cable tray was on correct condition or not. Whether my cable insulation quality or maybe the cable quality was correct or not. So there are a lot of other things which went wrong, and if we don't act on that, ultimately it can cause again the incidents back, right? And that is the reasons behind that, why we have to understand all the three causes. And again, I am not going more on the theory part now, because we will see with the real incident, right? And then we can exactly correlate with each other, right? Okay, and the second part we have to understand is the human failings, or sometimes called human errors, and that's what the normally any incident happens. People say it's very simple thing. Someone has done something wrong, right? Or maybe that person was not knowing, or the person has not used the personal protective equipment, or the person has kept this equipment at the wrong place, right? Or maybe he has operated incorrect switch, right? we normally give a very simplest answers in our identity in casual factor. These are the failings happen. So first of all, we have to understand whether it's unintentional, intentional, or normalized. Unintentional, I think we know very clearly. You can see through the picture also. When you see from the picture here, 1 minute. So when you see from the picture here, what you see here is an unintentional deviation, right? That person doesn't want to hit his finger, right? But because of the nail gets bent and ultimately instead of a nail, he or she hit the hammer on his or her hand, right? That's an unintentional deviation. There are 5 or 6 switches in your home even, right? Sometimes it's for fan, sometimes for your other lightings, and then instead of fan you start the other lighting. That's what the unintentional. You don't want to do that deviation, but it happens. It's unintentional, right? And that sometimes you there are multiple boxes and you select the incorrect box. That's what the unintentional deviation. Now, coming back to the intentional deviation, I think we know that there is a what is the right way to do it, but we don't want to do that, and that's the intentional deviation. And the last part was on the normalized deviation. That is again the intentional, but the difference between here is because of routine practice. Even though we are doing a wrong thing, but because of the routine practice, we think this is the right practice. We can do that. Everyone is driving 100 km per hour in this road, even though speed limit is 80 km per hour. That becomes a normalized deviation. And then, like what the current situation you can see in COVID-19 now, people thought that now COVID is gone and I don't require now mask because because no one is using it, and that becomes intentional behavior, normalized deviation, right? And through the repetition has become an accepted practice. Now, why these failings required to understand? Because if we understand the failures, then we get the right cause of the incidents also, whether it's unintentional or intentional deviation, whether someone has done willingly or not willingly, intentionally or unintentionally, right? And then what we can get from the investigation. So the fundamentally, what went wrong? That's what we normally get, right? That's what the purpose we will want to know that the incident happened. Let's say there's a fire incident happened. What went wrong? Whether there was an issue in terms of electrical connections, or maybe they haven't done the inspection correctly, or maybe the firefighting system, the mitigation factor was also not effective detection, or firefighting system was also not effective, or maybe the ventilation was not right, or ventilation doesn't have the adequate design engineering system was there so to cut off the air supply in case of that, or maybe exhausting the smokes and all design was not done well, exits are not well designed. So that all those things what went wrong we understand from that, right? And maybe the people have not responded, how it happened, what was they were creating, what how it's initiated that incident, right? That we get to know, and why those things. So this is what we can get a lot of insights from the investigation. We get the true snapshot, what actually happened, right? When you see at the picture, you find out a lot of things there, and you get to know that what actually happened. And then error traps and precursors. So we have seen that, right? There are three parts: intentional deviation, unintentional deviation, and the normalized deviation. Now, any deviations to happen, there is a error behind that, right? And how this happens, why we do the unintentional deviation? We want to do that? No, we don't want to operate the incorrect switch. But why it happened? Because the switches have the similar color, or maybe the connector have the similar type of features, or maybe because of the pressure I have to do this work in very short time. That was the situation. Is there a work environment issue? There was a very noise environment, and what the one person has said to other person, he was not able to listen clearly. So that has created those errors, right? So this is what we have to understand behind it. Why this normalized deviation? Why is the unintentional deviation? Why this person is doing intentional deviation? Is there something issue with their families, or is there something with the cultural issues, or some? These are all we have to understand through the error traps and precursors, and their learnings. So we get a lot of things. What we said very important. The similar incident we can stop in the future, and that learnings can be shared across the other sites or the locations. So I'm sure now it's clear for you that what are the information and insights we can get it from the investigation. Now, coming back to the methodology, because with the first part, I'm going a little bit faster because what we are going to spend good time on case studies rather than spending, because these are some of the very basic fundamentals. But I just want to brush up some parts because That's what you can get. Now you can correlate with the next parts once it comes. So any investigation happen, what is the first step you do? Someone say that, okay, the first part I will do is that to get treatment, medical treatment to the person and send them to the nearest hospital, and the right treatment has been done in the make area the safe. That's the first part. So that is always there. When investigation starts, what you do is you immediately survey the area, right? That's what you get a true snapshot. What happened? Whether there was a wall there, some caps were not there, some chemicals or some spillage happened. A lot of things you'll get to know once you survey the scene area. Immediately secure the scene so no one can touch and no one can disturb that areas, and that is very critical. You can take a lot of photographs, collect evidences from the different angles. You can do the measurements of the different requirements, and then you do the interview witnesses. Now again, when you do the witness interviews, what is the right method? Can I do immediate or should I wait? Any answers on the chat box? Because I'm going to do that part, because even the last session is definitely will be a question and answer session, but you can always write down in the chat box what is the right time to do the witness. Can I do immediate or can I wait for 1 hour, 2 hour, or can I wait for 7 days? What is the right time to do that? So the right time is always as soon as possible, right? So that what you cannot lose that evidence, and then there is always you will find out there is a difference in the statements as the times goes on. Because in my years of experience, what I have seen that the person who has speak on that day, and if you don't record that statement, and the second day you will again ask the same questions to that person, you will see the different statement. And that's a very important part, that better to take the statement, preferably recorded statement, and then that's the right way to take the more and more number of interviews and choose the right witnesses to get the right feedback. And nowadays also you can use some of the other various technology like open-ended question. That's a basic fundamentals, rather than asking the close-ended questions. And once you get the data, and now this is what preliminary work is done, because sometimes what happens if you don't do this preliminary work better, very difficult to analyze the data, because you are just collecting the data, but the data quality and all, if it is not correct, what happened when you start analyzing the data, you found out that this link is not getting happen. And that's what, because you miss something, you haven't collected one data, you haven't collected the data. And that things can happen, but what happened over the period of years and years of experience, the possibility of getting miss out will be very low. Okay, and that's what you can do it. And then you determine the causes. So again, the causes, the immediate causes is always the first. Second, you go to the underlying causes and then go to the root causes, right? And based on the root causes, you identify the corrective actions. So again, what is a correction? Corrective actions. We will touch up a little bit on that front also. But corrections is normal, like you do containment action immediate. So if the incident happen, you save someone's life, and then you can do that, and then you ultimately make that area safe. So that's what before that activity. And some also short action also you do that. To temporary that again some activity can be restarted back, but corrective actions are really different, so that we'll see that part in subsequent slides. Fine. So now coming back, who should investigate the incidents? Now we say that, okay, these are the mostly happens that when supervisor, manager, safety officer, safety manager, safety heads, who should do the investigation. Ideally, based on the type of incident, you can choose the team. Preferably, you can have a multidisciplinary team and the right team, because not only that, because we require all 5 varieties, so we can keep any people in that team. So we have to choose the right people, because they should know, first of all, what are the incident causation model. So how the human errors, error traps, what is intentional, unintentional deviations, human and organizational performance, ABC, a lot of other fundamentals, and occupational health and safety terms, industrial hygiene, chemicals, lower flammability limit, lot of other clarities to be there required. Like someone is going to investigate the process safety incident, they should know what is a pressure relief valve, what is bursting disc, what are the layers of protections, how the multi-gas detection system works, when it gets poisoning. So a lot of very great understanding is required in terms of before starting investigation on that. Interview techniques, again, that's also a good practice. Is what I said. One is definitely open-ended question, but you want to get more and more information from the others. So how you can get that from more information is doing the interview rightly, right? How you do the interview rightly? Asking very short-ended, very fast questions? No. So you should be very cool. You should understand that the first of all the scenario better way, and then you choose what are the right type of question. You should frame questions before going to the interview, because that will give you much better. Because what you understand a little bit about the survey scenarios and all, so you can frame your question and then you start interviewing, and that's what the interview your right techniques to be used. Then root cause analysis. So we'll see that in the subsequent slides on what are the techniques can be used. There are hundreds of techniques, but which are the most famous method or some of the easiest method you can use it based on the again type of incident you can choose it. And then legal and other requirements, and then you should be able to analyze the data. Sometimes you require to understand also on the statistics and probability, because if you don't do that also your data will not give you the right results on that. So all those require skills on that. So you can have a multidisciplinary team, but this knowledge and skills are required across all the team members. If these team members do not have those skills, your investigation will not give a good success on that. Fine. So let's move now. Next part. Now questions to the audience. Now you can use your chat box and choose the right option. What is the main purpose of incident investigation? It is to find out who is at fault, so we can easily catch them, place the blame that this person has done wrong and that's what this incident happened, or prevent similar types of incident in future, or discipline the individuals who are at fault. So we can find out, okay, that operator has done wrong, or maybe that manager has done wrong, or maybe the technician has not applied the correct lockout tagout. So we can discipline that. So what is the right answer? I'm just giving you 1 minute pause on that. You can just write down in your in the chat box. Okay, because I will at the end of the session I will see that whether everyone has answered the questions or not. Okay, great. So the right answer is to prevent the similar type of incident in future that we have seen very well, right? It's not for the other any other purpose. Okay, now we will move to the root cause analysis techniques and with the some examples. So there are multiple techniques. So these are the only few examples. So don't think that these are the only root cause analysis techniques. There are multiple techniques. Okay, but some of these techniques are easy and these are more famous on the industries. Again, someone said that HAZOP is also can be done. Yes, for the process safety, even HAZOP also is a proactive document. But once the incident happen, it also helps you to the for the investigation. Same thing like failure mode and effect analysis, that will also that. So we will see one by one a little bit on that front. Okay. So why incident? So this is the most easiest method to do that. But what happened, I've seen in the most of the industries, what they do is they put normally why in the single line rather than putting into this multiple whys. Because what happens, normally you will not, very rare case, you will find the single cause. Normally it is always multiple causes. Because let's say if the fire to happen, you cannot say the fire happened because of only the flammable chemicals. It requires flammable chemicals, it requires ignition source, as well as it requires a oxygens, right? So you cannot say that only one because of one reason the fire happened. There are multiple causations. So that just to give you some easy as to idea that it cannot be always a single cause, it can be always multiple. So that's what you have to go for, that one why had it happened. Maybe there are 1, 2, 3 reasons. For the one reason why it happened, this may be this and this, right? And then you go further, and then again you see that okay, to happen this, again you have a 2 whys, and there's not always mandatory that normally we call as a 5 why, but it can be 4 why or it can be 6 why. Not, but normally in by 5 why you will always end up with the basic causes near to the root causes. Sometimes you have to go some 6, or sometimes it can happen in 2 or 3 also. So depends upon the type of part, but normally in 5 why you will mostly you will be able to identify the root causes. Again, I'm not doing much detail because we want to again correlate with the case studies. So I'm just a little bit going to give little bit snapshot on the techniques. Second thing on a fishbone diagram. Now, fishbone diagram normally doesn't give the much on the root cause because it gives you more causes. Now, they are not mandatory that okay, you have to do only on the 6 7 parameters, and it has been it also called Ishikawa diagram. It was created by the Karo Ishikawa is in 1990 to identify what are the causal factors available with each part. So again, when we say the causal factor, it can be related to the equipment, it can be related to the process, it can be related to the people, management, environment, materials. You can use also method, you can use tasks. So there are varieties of you can identify the factors, not mandatory that only you do in the sixth part only. Okay. So manpower method. So so many times people use 6 M's, sometimes use. But the important part that it should be in link with the type of incidents, and then you identify what in the process what went wrong, in the people what went wrong, whether there was a competence issues, whether there was training issues, in process whether they have not followed the right methodology, right safety procedures, permit to work system was not correctly followed, equipment was faulty or not, that's not maintained well. So you get to know what are the causes behind that, and then you identify multiple causes which lead to the problem, and that's what called the Ishikawa diagram. Okay. And then the another is a fault tree. It's again a deductive methodology. We use logic symbols, and it's a top-down method. It has been developed by the Bell Telephone Laboratories in 1962, and that's more famous on U.S. Air Force, and it was later more adopted and you applied by the Boeing company. Now, this is also very good tool. So when we say this tool is also called system safety techniques, more on the proactively, it's also hazardous analysis techniques because you can identify the hazards also based on that, and then you identify what is the probability of failure, and then you at the end what is the overall probability to get an accident. So that's also we do it use the faulty analysis. But the same way, the faulty can be also used as an incident investigation tool where we can identify what went wrong and ultimately identify the basic causes on that. Okay. Failure mode effect analysis. So sometimes critical components, crane, or some critical machineries where there's a because of small components fail, like in crane, there's an encoder which gives a feedback for the speed and all. Now, if the encoder fails, what it triggers to the others failure, right? So that what it also helps you because FME what you do is that you go into each component by component, then you go be sub part, what are the impact to the sub part, and what is a possible failure mode of that, whether it's a failure to engage, failure to operate, or whatever, right? And then you identify what is the probable reasons for that failure, whether the what is the reasons that the limit switch can get failed, or maybe the brake gets failed, or the engagement or motor can get failed, and then you identify the right proactive actions on that. But if the incident happened, definitely there's just some gap, right? Either you missed to identify some of the failures, or possible that you didn't identify the right actions to mitigate that failures during the FMEA. So that tool also can help you to identify the causal factors for the investigation. Now, this is also the one of the good techniques, most famous in Europe, is called man technology and organization. Or sometimes it's called human technology and organization. HTO also it is called. So what we do identify is what went wrong in all the three parameters. Technology, what went wrong? Is there some failure in terms of machines or in terms of guard interlocks failures, or all these things happen, or ventilation system failure? That what you do on technology part. Organizational, you will see that your procedures, your authorizations, your audit system, inspection system was failed, training system failed. And then on man part, again you go for the human factors part at the intentional or unintentional deviation and all. And then you use the structured analysis, change analysis, and barrier analysis to identify to do the again the identify the possible causes for that incident. Okay. The another nice tool is a bow tie diagram. Bow tie diagram is again the simple tool where here you identify the top event, okay, based on the hazard, and there is a threat which can lead to a top event, and because of the top event there can be the consequences, right? Now, the threat gets converted into the top event, you put some barriers, right? That we call as a preventive barriers. And when the top event, once the event happens, let's say that load fell down from the crane, that's a top event, okay? Or what will happen? It can crush someone, or it can danger. It can, if it falls on the electrical panels, it can cause arc flash or incident. So that can be the consequences. Now, to load to fell down, what is the threat? Maybe there is a strong wind. Maybe there is a possible that the rigging sketch, the load is not correctly lifted. So that's all possible threats which can lead to that incident. And then you put a lot of barriers. That what you do, you make sure that there is a competent person, there's a preventive maintenance checks are there, there is a light safety devices are there and they are functioning on that. And sometimes you put some escalation factor also to see that this preventive barrier is also again has some additional barrier to because that can trigger that part also. That, for example, authorization, but there is a training and assessment can be your escalation factor, that training is also effective or not. So you use that tool and then you put a preventive barriers and then you put a recovery barriers. Again, this is more hazard analysis techniques also. It can be used more on the risk assessment part, but that is also can be used also for the investigation, because you will get to know how the incident happened, which barrier failed, where there is a preventive barrier also failed or recovery barrier also failed, so that you get to know. And second thing, why barriers were expected, so what was the purpose, and that was initiated that event, so you get to know that after that investigation. Fine. And then we'll go a little bit on the strength of defenses. On strength of defenses, again, when we said there's a layer of defenses, right? I put the very simple examples, right? To fire to happen, what you do for the prevention part in your office or either in your home, what you do. So you said, okay, sir, we have a strict, very good policy for no smoking. Or what we can do, we said that we will ensure that in our store or in our home or in our office, we don't allow to store any combustible materials. We carry out the daily monthly safety inspection. We have a strong MCB RCCB protection, arc flash current interrupter, and then I'm doing infrared thermography. All those steps I'm doing to make sure that fire will to prevent that. I want to do that, right? That's what I want. I'm doing that, right? But if I put all those things, do you think that I should put other parts? Yes, other parts are also required, because that's what we call as a human error, right? The human error happens. We say sometimes the no smoking policy, but there is always, you find sometimes failures. You say that we have a very strong policy on combustible materials management, but you someday you found that in your offices so many documents have been stored, right? And sometimes you also found that electrical connection and protection is done, but they put inferior quality, or maybe they haven't done the inspection correctly. So there is always possibility of error can happen. So what you do, you put a next layer. You put some catch and detection. So you put your smoke and heat detection. So if any even the things fail, there can be some consequence happen, but it can be minor. And then still someone can act on that. It again, you require intervention, because someone has to go there and extinguish the fire. And then third part, you put a mitigation on either the sprinklers and firefighters or the portable fire extinguishers and all. So you put all the layers of mitigation. That's what we said even in the bow tie also. Various layers of defenses you can put to prevent the accidents, right? Now the same thing, it will help you for the investigation or not. Once the incident happened, let's say the fire incident happened in one of the hospital or one of the building, and then you go with these defenses, and then you get to know that what are the defenses have failed. Okay, maybe the detection system didn't work, someone has not done the maintenance. No smoking policy was there, but even though there are few cigarette butts were found in that area, then you found that the electrical inspection, never ever someone has done the inspection, even the wiring was not done as per the even national electricity code, right? And then the right side, on that side, you see that the extinguishers are not maintained, no emergency contact numbers to immediately communicate, sprinklers were not there. So that ultimately you found out that multiple things went wrong and ultimately resulted into the bigger fire, right? So that also helps you to identify what went wrong in that each factor. And that's what you can use the simple tabular form. Like I put it one form, confined space. What are the layers of controls you have? That's again the engineering controls. Some controls are prevention part, some are on mitigation part. some things on PP and cultural defenses part, right? And then you identify which cultures, which defenses are was working, which were failed, or which were not a methodology. So any of this methodology you can use to identify the causes of the incident. Now, following are the examples. Now, this is a very little bit tricky. I think I am expecting everyone to read carefully. Following are the examples of root causes, except, so there is a one which is not a root cause. You have to identify which is not the root cause out of all four. Okay. So read the question. The first option is periodic safety inspection is not being carried out to proactively identify deviations which may lead to the incident. The operator was not competent enough to apply lockout tagout, which is normally done for isolations and all, for energy isolation during the maintenance. And the defective ladder caused an injury. And the crane operator training and practical assessment is not ensured as per training needs identification matrix. So, what's your answer? Either you can write A, B, C, D. That's also fine. The first is A, second is B, C, and D. So, there you can select the right options on that, which is not the root cause. Fine. So the right answer is the defective later cause an injury, because that's an immediate cause. It's because that's an agent cause. Why the defective load later was that? That's the next part you would ask to get the underlying causes, and then you go to the root causes, right? The others are all the examples of root causes because that can be done from the why. So you can get to know from that angle, right? Okay. Now coming back to the investigation philosophy. uh, when we do a lot of investigations, what happens? We missed out sometimes because of to identify the right causal factors. Is like there are a few examples I've given, like resource constraints. Why the person has not used that equipment? Sometimes we said, okay, I've seen many times the very funny videos also in the WhatsApp University also, and sometimes the real incident also. And someone said it, okay, one person was standing on the forklift to do some work at height. Now the question is to the management whether we have provided the right ladder to that person, right working platform or mobile elevated working platform, and he has not used it. Then we can say yes, there is some issue with that human error, or maybe that's intentional deviation. But we have to understand that part also, whether we have provided that resource. So there was an issue in terms of whether we failed to provide the right resource for that type of work, or someone is there to assess that risk. So that failure we know never we identify that that person has done violation, has done intended violation, intended action on that, right? So identify that. So that's what I want to little bit get time on that, so to understand that whether is there issues in the flawed processes or in the deficiencies, or is there reporting in our near, we have a multiple near misses are happening but we never do the analysis on that front, or the type of variety of errors, or maybe the defense is very inadequate. So think on that all the perspective while we do the investigation. It's not only that just go to that and then we say that okay, that go to the immediate cause and we close now the event. Understand those all philosophy before reaching to that right corrective action. If you happen, right, and that's what the part, and then what we were discussing on the correction and corrective action. Now, when we say the corrective action cannot be done without the root cause analysis. So you is ultimately because you have to eliminate the cause of the event to prevent the recurrence. The cause of the event is always the root cause normally, because otherwise it will happen. So to prevent the recurrence, so you have to always do the root cause analysis. Based on that only you are able to identify corrective actions. Correction you can do immediate. Like there's a what I have given many examples, right? So there's a blade and someone gets cut, you remove that blade. That's a correction. You done it, right? But what is the corrective action? That's what you have to understand the cause behind that incident. Okay. Once you do that, put the right corrective action, put the right responsible person, target date, track through the various methodology. You can do quarterly, monthly, weekly review based on the type of incidents. You can use some action tracking application, so it gives you trigger that the still accidents are not close on time or not. And there should be email notification system so you don't miss out on those aspects. So these are various you can way to make sure that you don't miss out those parts. So just to have one small video for all of you. Again, this is doesn't have a voice, so don't worry on that front. Sorry. 1 minute. So the purpose of showing this video is so when some incident happened, they got to know that because of the coiling effect, because of the induction effect, it gets heated. And what happened is that there's a near a flammable material was there. He kept the flammable materials away, but he forget to kept again the new ignition source. And then okay, that the incident happened. And then what they identified, there's an issue, and then he said suggested the right actions on that. Okay, again it's corrections, not a corrective actions. So what happened? Correction he has suggested. The incident happened again. The different type of incident happened because the correction was were not effective even because whatever the right way he was saying. So that's what very important. Once you do the correction and corrective action, and then you define on that, make sure that it's done effectively close because he has done close haphazard way, not a right way, right? What happened again? The maybe not the same incident happened, but the other incident happened, right? So the important make sure that whenever the incidents happen, make sure that we do the right corrective action and then we verify the effectiveness. So that is very important. And the third part is the deployment. So normally in most of the organization, what happens like there are multiple sites, there are multiple plants are there, right? There's not only one plant you have. So what happened? One plant, the incident happened. They do the nice investigation, they do the right corrective action, but they forget to communicate with others. Now, to forget to communicate with others, what happens? The incident can happen to other locations. So, what is the best way to do it? There are multiple, even nowadays, you can use some software application also. We use that one of the applications. What we do is we convert those corrective action into the questions. Like, for example, one question is covered. It's like, is permit to work? Issuer assess risk and ensure risk controls prior to issue permit to work for all high risk operations. So, like, let's say I'm at X site, or I am at the Y site, or I'm at the Z site. So what I have to see that whether I am following for all my high risk operation for confined space, lifting operation, energized electrical work, or lockout takeout work, whether my person goes and really assess the risk and ensuring the risk controls are in place. Okay, is lifting plan is being used for all my lifting operations, and the lifting plan should contain the risk assessment, rigging sketch, load capacity, and then any other specific requirements. So what happened now? Those learning you convert into the questions, and then you ask every sites to report on a monthly basis. Like for example, the site one said yes, we are doing that, but site two said yeah, it's still not do. So they will take as a corrective action, and they track that actions with their that particular site, right? And you can also do the external assessment quarterly to thorough checks that yes, all the 10 or 15 questions which are being done on two or three incidents or maybe 10 incidents, and that is being really effectively acted across all the sites or across all the locations. So that is what very important to share those learnings, and that is convert and track it. So sometimes many times we do the email communication, this is our investigation report, and we throw our corrective actions to the other sites, but we don't track that. So very important that track those actions, And then you can even one of our indicator is that on that front also, that the actions arrived from the horizontal deployment actions, how many percentage of actions are being closed on time. So that is also is a part of your systems, can be your indicator. So that is what you can do really, the horizontal deployment of learnings. So that's what I've done my the part one. Now I'm going to the quiz question 4 on root cause analysis is required to determine corrective actions. I think this is a very simple question. Yes, it's required. And the question 5 is the follow up of corrective actions and effective verifications are not important. Are you in agreement or no? You will say yes, no, right, or no. The right answer is false because they are both important. If you don't do the corrective action, proper follow up, and proper with the target date, responsible person, and tracking, it will not give the right results. And the same thing, effectiveness verification also very much important. That is not today they have done some action. Someone has said, let's say, training assessment has been done and only qualified persons to be deployed. And tomorrow you find out that out of 5, only 2 people are qualified and the other 2 are also working. So that's your effectiveness was not there. So that is also very important that you have to see that the effectiveness also is verified. Okay. And then the last questions of this part on the quiz part. Now, which of the following is the most appropriate corrective actions after electrical shock incident investigation? Now, when we say corrective action, what should be the right corrective? One person said that we immediately damage the power cable with insulation tape. Someone has said that we replace the cable with a new cable one. The third one said that rerouted the power cable such that the doors does not come in contact with that to prevent the insulation damage again. And the instruction provided to stay away from the power cable. Now, what is the right option? A, B, C, or D? The right answer is C because the others are are only the corrections, not a corrective action. Fine. Now move to what we'll do is we'll do the one case study in the interest of time because I have put 2 case studies because but we'll do only one case study. If you have time, we can go through the case study too. Okay. Now because that's what we want to link what we learned it right. Now this is one incident happened. One of the welder was welding one of the channels. You can see here. 1 minute, I'm using my uh, laser pointer. So here you can see there's a steel channel. One person is doing the welding here, and he was standing on the one of the 200-liter drum, uh, and that was filled with some residual isopropyl alcohol. It was almost 75% concentration, and while doing the welding, suddenly that there's a flash fire happened, and that person received the burn injury. Right. Now, seeing this incident, I will take just 1 minute for all of you. What do you think? What went wrong in this? Now, I've given the full scenario, right? The person is doing welding. He's the authorized welder. He's doing the welding. He has to use, and this was done in the areas which was not very easily visible. It was near to the some of the stairway areas, and someone started welding, and suddenly that there's a flash fire happened, and the person received a burn injury. Now, what do you think that what went wrong in this? Please write down in the chat box. I want to see some of the good insights on that. And I want one is that what should be the immediate underlying causes, and maybe something can also put the thought on that. What can be the root causes, possible root causes? I'm sure not. You cannot get the exact root cause because you are not part of that incident investigation team. But based on the scenario, what do you think that these are the probable possible root causes that lead to a serious incident? Okay, your time starts now. Everyone, please. Okay, I'm moving to the now next slides now. Okay, and that's ultimately lead to flash fire. Now, this was the scenario. What are the evidence you found out? So you found out this was the HTP container. One lid was closed, one lid was open. You found that this was completely ruptured. There was a welding shield you found nearby. You found out some welding holder, gloves, and there's some welding cables you found out. Okay, this was your survey the scene, you cordon the areas. That person has been sent it to the medical hospital, and then person luck. This was because the very quick treatment was that, and that person was able to do not receive very serious injury, but it would have lead to even the fatal in that case if that was not done on time. Now the these are the some I'm just because again this is a very big investigation, but I'm just giving you some of the snapshots of the investigation. Now, when you do the fishbone analysis, what we found out, one is we found out that welder was not in terms of people, welder was not competent enough to recognize the fires because where he was standing, that IPA is a flammable liquid, and the whatever the container he was using as a working platform was containing the isopropyl, and it has open lead. One of the lead was open, and he was not able if there's a vapor happens, and if there's a three things as combination, it can cause a fire or explosion. So that's what he was not competent enough to recognize what is a fire risk. Otherwise, he would have removed all those fires. He might be knowing that the paper and everything gets fired, but he was not aware about the properties of flammable liquid. Now, chemical storage and use and disposal procedure, because how the that container came into that location. Ideally, any chemical should not come to the general locations area. So that was also not followed. The container makeshift arrangement was used as a working platform. Hot work executed. So that person has started without making sure that the 10-meter area is free from flammable areas, right? Horizontally, vertical, it can be 50, 60 meter even. The PTW risk were not assessed and controlled. So permit to work, someone has issued the permit sitting from the office, not visiting the place, and just say that you can start your hot work there. That's all. PTW authorization. So the person, even the person who has issued the permit, he was also not aware about the properties of that chemical. What happened? What is the flash point? What is LEL? What is UEL? Lot of things. So he was also not aware on those aspects. Now the container was filled with IPA that used as a work platform. The ladder was not available. That's what he has to use that container, right? And then permit was not checked. So these are all casual factors to identify on the management, method, people, and all. So I just given one example. Again, you identified the casual factors. Again, you go to the YY analysis. This is the most better methodology to get the right root causes because you can get the immediate underlying causes as well as you can go to the basic causes. Now, came in context, I'm not going directly to that one by one each part, but what are the major the significant causes is that not provided the adequate resources, because if they have been provided the right working platform, you would not have used that container as a platform to work on that. The welder has not followed. Even he was aware that part. If there is a danger, he would have stopped that. But he has not followed the stop work authority that he can stop that if we found any unsafe act and situation that I don't have the right working platform. I will not work that locations. Right. So that is also failed. PTW issue, that's what I said, is issued without seeing that what are the risks, and he issued the permit without looking for that. Cut additional risk, last minute risk assessment, nothing is done. Was incompetent welder. Chemical storage was procedure also not possible, because anything is like empty container, you should have a procedure called decontamination, and then it's to be disposed as hazardous waste, and it cannot go to the any other routes. So that should not be accessible to any other people. So that was also not followed. And so these are all the things went wrong, right? You can use, even I put some multiple examples. So you have seen that the first I put the fishbone, I put the YY part, I put the faulty analysis again. So again, you can see that here you can use and or gets. So these are the reasons. These are probable the three reasons. The oxygen is definitely available in the environment. Now is used as a platform. Again, you bifurcate to A, B, C, D. Again, you go to the further drop down till you get the basic causes, right? So that is also the another methodology you can use as a faulty analysis, and then you get to know that what are the immediate causes, right? So the IPA vapor, which is the concentration within the LEL and UL, the range is normally 2% to 12% for the 70% isopropyl alcohol, and even the flash point was around 11 to 12 degrees Celsius closed cup. So and at that it was the right atmosphere, and there was a 4 to 5 liter residual isopropyl alcohol was there. Oxygen is definitely there in that environment, and the spark entered from that open lead, and that resulted into the flash fire, right? So that was again the immediate cause, right? And we end up the investigation here. That's not right? So we are already seen that, right? What are the underlying causes, and then what are the root causes, right? So these are the same root causes which we discussed. Uh, are we on time, or should we? Can we go with 10 minutes more? Hello, scene.
Hello.
Am I audible?
Hello.
Yeah.
Yes, sir. Audible.
Yes, sir.
We
Audible.
can go for
We
five
can
more
go for
minutes.
5 more minutes. 5 more minutes, right? Okay, so I will just do some one or two parts on it. Then that's case fine. Okay. So same thing. You identify based on that the right corrective actions. Now a little bit on going not too much on the case study too, but just to give some idea because one incident I have taken a little bit on the hot works related. This is more on the lifting operation part when the one person has to lift that one trestle, and while lifting the trestle it's a little bit more that side on the other side, and that person is hit by that one of the trestle. Again, that was just a medical treatment incident, but it would have lead to a fatal also in slightly different circumstances. Now that crane operator was operating, and when he's operated a little bit slightly up, there was a little bit pivot point was here, and the distance between two trestle was very low, 1050 mm, and he has to put ultimately because this was not very stable, so he has to put this. You can see that part is a wooden pieces, so he has to little bit insert the wooden pieces to make more stable. So to put the wooden pieces, he required to lift it little bit. So he thought that's a lunchtime. Let's do that. Even he was not authorized crane operator because he was failed to do that. I will go to the root causes part later on. But then he started to operate little bit. So once he started little bit slightly up, what happened because of the pivot point movement? It slightly moved in that direction, and it hit that person, and he got some injury on the back. Right. Now, I'm not going to all the fishbone, but I'm just little bit going more on the bow tie part because this is also one of the techniques what I want to little bit on highlight on that. So what when you do the bow tie in a bow tie diagram, again you see that there are some barriers. We use the right lifting plan, that was not done. The review the load capacity prior to the lift, that was also not done. Assign the right rigging team, that was also not done because they both are incompetent to do that job. Limited lift stability check. So before doing any lift, what you do, you make sure your 1.5 edge. So for example, your job height is 2 meter. So 2 into 1.5, so 3 meter area, minimum 3 meter area. You kept free from any human occupancy, and make sure you slightly lift it. If the load is stable, then and then you will move it. No person in that lifting zone. So that was also not done, right? And then on the operator also incorrectly was incompetent to do that. Practical assessment also he failed to do that. He was not passed that theoretical and practical assessment for the crane operations. Also, that also went wrong, and there was also no monitoring was done either CCTV through or either by supervisors. So those all those things went wrong, and even on recovery parts, the area was not cordoned off. Otherwise, if the area was cordoned off, it would have hit only the other vessel. It would not hit that person, right? So that what all the barriers have failed, and that also give you the what went wrong in the causes also. So more the hazard analysis tool, but that can also help you for the investigation. Same thing like strength of defense matrix. You can use the what are the layer of control you define. The defenses were there, but that was not in place. So that is what when you define the risk controls, the important part is always that the defense is to be checked periodically. If you don't do that, it will result into accidents. So any defenses or any risk control you establish, because that's what we have as an organization, we have a practice that take a one seat as an inspection for each operations and see that your defenses are green or yellow or red. And if they're red, immediately act on that. So that's more proactive because this is what I'm doing is on reactive part because the incident already happened. Which barriers have failed, and that barriers again you can work it out and then take a right corrective actions. Okay. So these are all the different causes, and then you identify the right corrective actions. All right. So that's all on the at the end. We are now able to understand what is the incident. We understood why important to it because we can prevent the future incident as well as similar type of incident, and we get to know the what are the causes. True snapshot. We understand the error traps and precursors, right? And then we get to know that learnings can be shared to the other organizations. We understand the methodology from the starting from the survey to the scene to the end of the follow-up, right? so that we all understand the right steps. Very important on the right data collections, witness interview, what are the different stages we understood in a very short time. And then we understood there are different techniques. You can use you can use any type of technique. So there is no mandatory. Most easiest and simplest, which give you good results, are YY, and that's what my experience. And but for the process incident, you can use HAZOP, you can use LOPA, you can use bow tie, you can use strength of defense matrices, where you can identify what are the barriers have failed, and then you get to know. Fishbone diagram is also one of the famous, where you can get on each parameters, man, machine, or process or equipment, what are the things went wrong in that, primary causes or secondary causes. And then you finally go to the follow-up actions. Follow-up action, again, how you deploy the horizontally, this investigation. And then when you do the investigation, the corrective actions are, you again relook on those action and see that if I do this all corrective action, really this incident will not happen. If yes, if all these answers will come to yes, then your investigation is correct. If still you say that okay, after taking these corrective actions, the incident still can happen, your investigation is not correct. So do that when you do the investigation, and review that, and then verify the effectiveness. That is very important. Periodically check. You can define your frequency as organization based on the size and the type, but very important part to see that. That's all from my end. I think I hope you might have enjoyed. It's again one way. Normally likes more three-way communication rather than one way, but I hope you might have enjoyed the session at least.
Yes, thank you, sir.
Thank you, sir.
Thank you for this highly insightful and wonderful talk, interactive session. And we have covered many techniques, right from qualitative to quantitative various techniques, and covering and linking with everything with a case study. It was really wonderful. Now we have some questions in the chat box. I'll take one by one.
Sure.
So the first question is, how can we find hazards of a newly designed system if only design data is available?
So that's what we call as a management of change process, right? You can do for any new modified equipment. So process prevention through design is the best way. So, but you should always involve the expert person based on the type of. So if there's any chemical processes involved, better to involve chemical experts who knows very well on HAZOP, as well as the properties of the chemicals and what are the parameters and the design features considered. So that is what you have to consider, the right expert people during that part, and that is the right proactive tool, management of change. And that the right time you do the hazard analysis and identify the right corrective action, so it will not end up into an accident. So that's a more proactive nature, but that's what you have to do that.
Thank you, sir. So our next question is, how can we develop statistics-based data-driven root cause analysis using analytics?
So data driven, yes, definitely. So you require a lot. So depends upon the number of incidents happen. Similar type of incidents are happening, and then you can always define is there any correlations are there or not. Again, because then you require multiple data types of organization. And as an organization nowadays, what happens like in my organization in last 3 years, we don't have even single lost time injuries. So nowadays we focus more on the proactive parts. So to make sure that our defenses are working fine and strong enough. But what you said correctly, there are many organizations where the similar type of incidents are happening frequently. But that data you can collect it. I think maybe Professor Mehdi, and I think you can take a class of industrial safety engineering, where they've given very nice. You can do the probability assessment also. There are multiple tools you can use it, and then you can statistically analyze that part, that there's again the probability of this incident is there or not, right? Again, the probability of each control. So first of all, you can analyze first that what is the probability of failure of that particular control, and to happen to the incident, what is the probability the incidents can happen. If it is comes to 10 to minus 4 to 10 to minus 6, or maybe like SL category 3 or in that category, then you're comparatively fine. If it's not there, you can work it out that you can strengthen your defenses, or you can put more layer of controls to do that. But yes, that's my answer. Yeah.
Yeah, thank you, sir. So I am taking the last question. BOTA
BOTA
analysis is a
analysis is a
combination of
combination of
FTA and ETA.
FTA and
Isn't it a
isn't it
hazard
a
analysis
hazard
technique?
analysis?
Am I audible?
Hello.
Hello.
Yes,
Yes,
sir.
yes,
Okay.
sir.
Yeah. So BOTA is ideally, these are all what I said is the fault tree analysis and all lot of things are hazard analysis. We can also call system safety techniques. Okay. So that you can proactively identify what are your preventive barriers and reactive barriers or maybe mitigative barriers to make sure that it doesn't result into the consequences or doesn't convert into the even top event, right? That is the purpose of this BOTA analysis. But once you develop that, and the incident happened, what happened, you can again relook on this part that some of the barriers where I thought that these barriers must function it, but that does not function well, right? And that has resulted into an accident. So that will help you to go back and see that system. I hope you got an answer, right?
Yes, sir. Thank you, sir.
Yes, sir. Thank you, sir.
Now I would request Professor Krishna to formally provide vote of thanks to our expert speaker. Over to you, sir.
Hi, Kevin. Yo, are you able to hear me? Are you able to
Hello.
hear me?
Yes, sir.
Yes,
Yeah,
sir.
I can hear you, sir.
Yes, sir.
Yeah.
Yeah.
Kevin, what a
What a
elaborate talk. Right from, I can say A to Z. You covered everything. Very nice. Very interesting. So if you had we given some more time, you would have done many more things. Incidentally, the incident investigation is one of our core activities in the CoE-SEA. One part of many of the incident investigations where technical investigation is required, that is also to be done. Let me also tell you, many people do the incident investigations, but ultimately you have to put the interventions. All serious recommendations should be fixed by fail-safe or fail-proof methods. I've seen most people want to go to for fail-soft methods, giving training and all these things. No. Most effective incident investigation is in Tata Steel. We never close the incident investigation unless the serious recommendations are fixed with fail-safe solutions. That will bring huge say benefits, and whole people will get appreciate. The workers will get appreciate, and they cooperate, and they keep giving the reports. Anyway, good. This is a topic which we can talk again and again. I thank you very much, and you will be our one of the resource for CoE-SEA. We'll be calling whenever we require your help.
Sure, sure, sir.
Thank you very much.
Sure, sir.
Thank you very much.
Thank you, sir.
I thank all the participants. Today we have huge number and the moderators, Ashish, Savik, and Seal. Also IIT for giving this opportunity to call people like you and share the thoughts. Thank you very much. Ladies and gentlemen, again next week, same time, we'll meet with the academic speaker this time. So some professor from very renowned university, either in India or abroad, he'll be speaking. Thank you. Thank you all. The session is ended.